Good afternoon, flippers. Today we are doing video 3.3. Our objective is I will be able to prove triangles congruent using the ASA, angle side angle postulate, and the AAS theorem, angle angle side theorem. Our IXL skills are K5 and K6, so make sure you're getting them done because this is a very hard unit on proofs. Alex talked to you yesterday about congruence, which just means that an object has the same size and the same shape, same angle measure and same side length. So today we're going to be looking at two more theorems that prove congruency. Angle side angle transcongruence criteria states given two angles ABC and A prime B prime C prime, our new triangle, the measure of CAB is congruent to the measure of C prime, A prime, and B prime, and line segment AB is congruent to A prime, B prime, and the measure of angle CBA is congruent to measure of C prime, B prime, and A prime, then the triangles are congruent. So to put that in easier language, triangles are congruent if any of their two triangles and their included side are congruent. An included side just means that if we have an angle and another angle, the included side would be the one in between them. And that means that these two triangles would be congruent. So make sure you wrote that down and have that in a list somewhere of all your theorems that prove triangles are congruent. Our next one is angle side triangle congruence, AAS, which states given two triangles ABC and A prime, B prime, and C prime, if AB is congruent to A prime, B prime, a side, and the measure of angle B is congruent to the measure of angle B prime, which is an angle, and the measure of angle C is congruent to the measure of angle C prime, another angle, then the triangles have to be congruent. And to state that in easier language, the angle side postulate states that triangles are congruent if any two angles and a side opposite one of the two angles are congruent. So I'll show that to you now. So an angle, another angle, and a side opposite would either be this side opposite this angle or this side opposite this angle, and you only need one of them for this to be true, so I'll just choose this one. So let's say we have those three on that triangle, and this one, and this one are congruent to each of those three. Well, then the whole triangle has to be congruent. The two triangles must have the same size and same shape. And I'm sorry, but that's the angle side theorem, not postulate. It's angle side angle postulate and angle side theorem. Moving on to our examples. This one's a proof example. 1. Given M is the midpoint of line segment HP and the measure of angle H is equal to the measure of angle P. So now what I'm going to do, what Alex showed you to do, is to mark up what you have in your diagram. So M is my midpoint, and measure of angle H is congruent or equal to the measure of angle P. We want to prove that triangle MHC is congruent to triangle RPM. So if I'm looking at here, and that should be MHG actually. MHG is congruent to RPM. There. Now that I've marked up my drawing, I'm going to put in my given and my conclusion. My given is that M is the midpoint of line segment HP, right here, and that the measure of angle H is equal to the measure of angle P, right there. And that's my given. And then I put in my conclusion, which is that triangle MHG is congruent to triangle RPM. And I don't know the reason why yet. Now my second step, I know that I'm going to probably have to know an angle, and a side and an angle are congruent, so I'm going to try to find one of those that is congruent. Well, I know that line segment HM up here is congruent to line segment MP here, which I wrote right here. And why do I know that? Well, I know that because of the midpoint theorem. Because up here we've stated that M is the midpoint, and we know that midpoints create two congruent line segments. Our third step is we've solved that we've got two congruent sides, and in our given we know two congruent angles. So I'm going to try to find one other thing, a side or an angle that's congruent. Well, I know that right here I've got two rays that intersect at a point, which means I have two vertical angles, and we know that vertical angles create two congruent angles. So I know that HMG, the measure of HMG is equal to the measure of RMP. So this angle right here and this angle right here. And I know that because of the vertical angle theorem, because this has to be congruent to this vertical angle theorem. So now we know this angle is congruent to this angle, and this angle is congruent to this angle, and this side is congruent to this side. So we have angle, side, angle. So we can prove that the whole triangle is congruent to the other triangle. So triangle MHG is congruent to triangle RPM, and our reason is angle, side, angle theorem. Our next question asks us, is it possible to state the two triangles are congruent, these two? If so, state the postulate or theorem you would use to prove congruency. Explain your reasoning. So we don't need to make a proof, but we do need to state what theorem would allow us to make a proof. So I'm going to look and see what I have that's congruent. Well, I know that this angle is congruent to this angle, so I have two congruent angles, and I know that this is a right angle, and when we have a linear pair, and we know this makes a right angle, well, we know that this is also going to make a right angle because of the rule of a straight line is 180 degrees and half of that is 90. And now we also know that this side that we see right here, well, they share it. So it's almost like saying the side of this one is equal to the side of that one because it's the same side, right? They have the same side. So we have an angle, and a side. So, and because it's not an inclusive side, I know that it's the angle side theorem. Angle side. Because it's not here. If it was here, it would be the angle side angle. But it's actually angle side. And because of that, I know, yes, congruent. Okay? So now it is time for your secret hot question. 1. List all the triangle congruence criteria, theorems and postulates. So I want you to list all the theorems and postulates that you learned in this video and last video. So state all of them. Okay? I want to see those listed in your notebook. And then your second problem is given line segment AB is perpendicular to segment BC, and segment DE is perpendicular to segment EF, and segment BC is parallel to EF. Then, and AF is equal to DC, so AF is equal to DC. Prove that triangle ABC is congruent to triangle DEF. So this is kind of a challenging problem. I know you might not get this one. Attempt it, try, struggle, set up your given and your conclusion. At least set those up correctly. Okay. Have a good day, flippers. It's almost Thanksgiving.